Hello everyone, I am Dipam and this is our solution for the NeurIPS 2020 Procgen competition. So me and my teammate Quang have been really interested in the idea of generalization in RL, especially with all the recent works done in it. And I saw some videos from NeurIPS 2019 which also got me excited in this. So our final solution is basically a modification of phasic policy gradient where we made many hyperparameter changes and also came up with some novel ideas like recalculating GI on the entire replay buffer, augmenting the replay buffer during the auxiliary phase, some feature engineering approaches, and also mixed precision training during the auxiliary phase, which really helped us increase the auxiliary epochs. The primary idea behind recalculating GA is that the original PPG paper calculates the GA return targets for the auxiliary phase as the same return targets that it used during the PPO phase. Now those targets are actually calculated from a much older value function. So what we do is we predict the entire value function on the entire buffer again, and we calculate the new GA values and use that as the new targets. The augmentations we use are from the Nhat paper, the pad and random crop, and the colored cutout. So the simple hyperparameter changes that we made did give us significant boosts. The primary one being the channel scaling as we see in the original Procgen paper. So doubling the channel of course increases the compute, but we were able to fit that in, as well as reducing the gamma to 0.996 as well as frame stack, which is very important for some environments. We set the frame stack to 2 and that was pretty okay for most of the environments. Also using 112 environments did seem to give more cleaner gradients for a lot of the environments. And the learning rate schedule and reward normalization also gave some small boosts. So one cool idea that we had actually developed before the release of the PPG paper was that we had something very similar to it, where we had an auxiliary phase with a replay buffer, but we did not have the detached value head as in the PPG. And we also augmented that replay buffer and used the original value functions as the targets of the auxiliary phase. And that seemed to actually give a pretty similar performance to our final solution. So that's an interesting point to research further. One surprising finding was that a bug in our code that did not reset the reward buffers after each rollout actually helped us get more score in the leaderboard. But on investigation, we found that it reduces the variance of the rewards. But we could not get this to explicitly work, and only the bug makes it work. So this is an open problem for the research community. Some ideas that showed promise in some environments, but we could not get them to work on others, were a dynamics model for action prediction, adaptively tuning the gamma based on the episode length, feature engineering ideas, mixed precision training for policy phase, which seems to make things unstable, off policy methods in general, and even the beta VA for disentangle features, which seemed to be pretty good, but we could not get it to work for all environments. Finally, this competition has been a really good learning experience for us, and I really hope to take part in future competitions on the Procgen benchmark, and also that the research community does pick it up more, and also that off-policy methods can really work on this benchmark well. So that's it for our solution, and a big thanks to AICrowd and OpenAI for this competition.